Voyager 1, a spacecraft that was never expected to survive beyond its initial 4-year mission, continues to defy time and technology. Launched in 1977, it was built with systems less powerful than a basic cassette player, and yet, nearly 5 decades later, it is still sending back data from the outermost reaches of our solar system. What's even more astonishing is that this aging probe just made a discovery that has stunned the scientific community and captured global attention. The question on everyone's mind is, what exactly has Voyager 1 found in deep space, and what could it mean for our understanding of the universe? The story of this legendary mission began with a moment of genius. In the late 1960s, NASA engineer Gary Flandreau, working at the Jet Propulsion Laboratory, made an incredible realization using only a pencil and paper. He discovered that during the late 1970s and early 1980s, the 4 outer gas giants, Jupiter, Saturn, Uranus, and Neptune, would align in a rare cosmic formation. This alignment, which occurs only once every 176 years, provided an unprecedented opportunity. A spacecraft launched during this window could use the gravity of each planet to slingshot toward the next, drastically reducing travel time. What would normally take 30 years could now be done in just 12. Faced with this once-in-a-lifetime chance, NASA acted swiftly. In the summer of 1977, just 15 days apart, 2 identical spacecraft, Voyager 1 and Voyager 2, were launched to take advantage of this rare planetary arrangement. At the time, no one could have predicted the extraordinary legacy these twin explorers would build. More than 45 years later, they remain operational, continuing to transmit invaluable scientific data from the edge of interstellar space. Voyager's early achievements were already remarkable. The spacecraft sent back the first detailed images of Jupiter and Saturn, revealing swirling storms, vast atmospheric bands, and moons more geologically active than anyone had expected. Scientists discovered erupting volcanoes on Io and icy plains on Europa, features that completely rewrote our understanding of these distant worlds. Voyager 2 made history by becoming the first and only spacecraft to fly by Uranus in 1986 and Neptune in 1989. Delivering breathtaking data about their atmospheres, magnetic fields, and unusual moons. These discoveries were made possible by instruments that operated with extreme efficiency, even though they relied on a mere 69 kilobytes of memory, far less than the capacity of a digital photograph today. Despite the odds, both spacecraft endured the long journey through space. To reach their targets, they had to navigate the hazardous asteroid belt, something only the Pioneer missions had previously accomplished. Their route included a gravity-assisted boost near Venus, an experimental maneuver that proved key to conserving fuel and increasing speed. These innovative techniques marked the Voyagers as true pioneers of space travel. As they ventured farther into space, their endurance became even more impressive. The spacecraft recorded and stored data on track tape recorders before transmitting it back to Earth using just 23 watts of power, the equivalent of a small light bulb. And yet, these signals, traveling billions of kilometers, carried some of the most critical scientific information ever received. From mapping planetary magnetic fields to analyzing cosmic rays and solar wind interactions, the Voyagers delivered insights that reshaped planetary science. Now, more than 14 billion kilometers from Earth, Voyager 1 has reached interstellar space, where it continues to collect data on cosmic phenomena never before studied directly. What lies ahead for Voyager 1 is still unknown, but its recent strange emissions have scientists around the world speculating. Are they the result of a failing system? Or could they hint at something new, perhaps even something that challenges our current scientific understanding? Whatever the answer, the Voyager missions remain one of humanity's greatest achievements. They have journeyed farther than any object we've ever built, withstanding the cold and silence of space for longer than anyone thought possible. They are a testament to human ingenuity, curiosity, and the relentless drive to explore. And as long as they continue to speak, even faintly, from the distant darkness, their legacy will carry on, reminding us that even the most humble technologies can accomplish the most extraordinary feats. Here is your revised version of the script, rewritten smoothly in paragraph form without hashtags or headings, and with improved flow and clarity. The Voyager probes, launched in the late 1970s, were equipped with 12-foot diameter satellite dishes to facilitate long-distance communication with Earth. These spacecraft relied on radio signals that travel at the speed of light, but as they continued their journey farther from our planet, gaining about 3 to 4 light seconds of distance each day, transmitting and receiving messages became increasingly difficult. At one point, signals from Voyager 2 took over 18 hours to reach Earth. Compounding the issue was the growing background noise from terrestrial sources like radios, televisions, and cell phones, which made detecting the faint transmissions even more challenging. Despite these mounting obstacles, the Voyager probes have consistently defied expectations. Traveling through the vast emptiness of interstellar space, they have continued to deliver remarkable discoveries that have fundamentally reshaped our understanding of the universe. Their extended mission has taken them beyond the known limits of our solar system and into the mysterious realm of the Oort cloud, a distant sphere of icy, comet-like objects held loosely together by the Sun's gravity and believed to stretch halfway to the nearest star. Before reaching the Oort cloud, the spacecraft had to cross the heliopause, the boundary separating our solar system from the interstellar medium. This crossing marked their official entry into interstellar space. Initially, scientists estimated the heliopause to be located about 50 astronomical units, from Earth, and due to the significance of this milestone, NASA continued to fund the mission even as the probes approached it. However, the actual transition into interstellar space didn't occur as dramatically as scientists had anticipated. They had expected a sudden spike in cosmic rays, high-energy particles launched into space by supernovae and other energetic cosmic events. Normally, these rays are deflected by the heliosphere, a vast magnetic shield generated by the Sun that protects our solar system from external cosmic radiation. When Voyager 1 crossed the heliopause, researchers expected to see a clear shift in the strength and orientation of the magnetic field as the spacecraft exited the solar domain and entered the influence of other stars. Surprisingly, that shift did not happen right away. The probes recorded no significant change in the direction of the magnetic field, which puzzled scientists. However, on August 25, 2012, Voyager 1 finally provided a crucial clue. It transmitted data confirming a sharp increase in plasma density, one of the clearest indicators that it had indeed entered interstellar space. This finding validated theories about what such a crossing might look like, even if the absence of a magnetic shift raised new questions about the dynamics at play in the boundary region. As Voyager 1 and 2 continue to drift farther from our Sun, they remain silent pioneers in a realm few imagined we could explore. Their journey reveals not just the resilience of human engineering, but the boundless mysteries that lie beyond our solar system. Let me know what you think in the comments, and if you enjoyed this breakdown, don't forget to like the video and subscribe to the channel for more deep space revelations from Wave.